Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA 2021, paper 3, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1. B is 3 more than the square root of A. Circle the correct equation. B is 3 more than the square root of A. So the square root of A, 3 more than it, B is equal to. B is equal to 3 more than the square root of A. I think it's that one there. Question 2, circle the largest number. I'm going to rewrite each of these to 3 significant figures. So 0.5 with the dot on, that's a reoccurring decimal, isn't it? So that is 0.55, well, it'd be 55, and if I rounded off to 3 significant figures, then this would round up and it would become 556, wouldn't it? Okay, so just round it off to 3 significant figures so I can compare it. This one would be 0.550 to 3 significant figures. This one can just stay the same. And this one would be 0.545, well, it would repeat 45. So then if I round that off after 3 significant figures, then I'm going to be rounding down. So that one is going to stay as 545. Okay, so now I've got them done like that, then I can start comparing them. The first 2 digits are the same for all of them, so no change there. And then I've got a couple with 4s on the front and a couple with 5s on the front. So obviously the 4s are smaller, so they're out. Then finally I've got something with a 6 here and a 0 here. So it's this one, isn't it? That's the largest of the 2. Question 3, a line has equation 3y equals 3x minus 2. Circle the coordinates of the intercept of the line with the y-axis. Well, the y-intercept is the value of c, and the value of c occurs here at the end of a linear equation, okay, when it's in the form y equals mx plus c. Now, this is not in the form y equals mx plus c because I've got a 3y in front of it. But if I divided both sides by 3, okay, then that's going to cancel with that, and it's going to leave me with y. Well, what's that then? 3x minus 2 divided by 3. I want to kind of break that down a little bit. So I'm going to divide that 3 into the 3. That's going to give me 1. And I'm going to divide the 3 into the 2. And that's going to give me 2/3, isn't it? So actually, this is going to be equal to y is equal to x minus 2/3. Okay, so then this thing on the end here, then that is the y-intercept at minus 2/3, and it occurs when x is 0, doesn't it? Because it's the y-axis, which is x is equal to 0. So then the coordinate is going to be 0, negative 2/3, which is that one on the end. Question 4, factorize x squared minus 64. Circle your answer. Well, this is what we call a difference of two squares, isn't it? I've got x squared, which is a square, and I've got 64 that's a square because 8 squared is 64. Okay, so difference of two squares, factorize into two brackets, x and 8 and 8, 1 plus and 1 minus. Okay, so it's up there. Question 5, 6 positive numbers have a mean of 10, a range of 19. 4 of the numbers are 12, 7, 15 and 3. Work out the other two numbers. Right, I'm going to start with looking at the mean of 10 because I know if I can work out a mean by dividing the total of all the numbers divided by the number of numbers. Okay, now I know that the number of numbers is 6. The total of numbers I don't know, but I know the mean is 10. Okay, so I can work out the total of numbers then by multiplying through by 6. And if I multiply both sides by 6, look, I'm going to get 60 is equal to the total of all the numbers because they're going to cancel. Leave you with total of numbers on the right. Okay, so that means my numbers add up to 60. At the moment, I've got 12 plus 7 plus 15 plus 3. That adds up to what? 12 and 7 is 19, and 15 is 29, 34, and 3 is 37. So they add up to 37, which means that the two missing numbers are going to be the total minus the total of the 4 that we know. So that leaves 23. Now at the moment I've got, I'm just going to rewrite these in order. So I've got 3, 7, 12 and 15. Now I've got two extra numbers to add. Now the range is 19, so either the highest number then is going to be 19 more than the lowest number. So that could mean I've got like a 22 as my highest number, or I suppose it could mean that 15 was my highest number and my lowest number is going to be 19 less, which would be -4. So is it going to be -4 or is it going to be 22? Well, it can't be -4 because if they add up to 23, then that means the other number must be 27. So 27 and -4 make 23. So that one's out. Can't be -4. So it could be 22, couldn't it? So if it was 22, though, I've got a problem because I've got one left over. And that means I'd have a 1 here. And now the range isn't 19 anymore. Now the range is 21. This is a slight problem. What about then if it is 1 less than 22? Let's change it then. Let's say, well, it's not 22 then. Let's try 21. So it was 21 instead. Then the lowest number would be 19 less than 21. It would be 2. Does that work? So I've got 2 and 21. That makes 23. And the range between them is 19. So that does seem to work. Okay, so 2, 3, 7, 12, 15 and 21. So the two numbers are 2 and 21. Question 6. At a country park, there is a house, a museum and a garden. The table shows the price per person to visit the park. So the garden only is free. The house and the museum is £12.50. The house only is £8 and the museum only is £7. One day, 480 people visit the park. 67 visit the gardens only. 40% visit the house and the museum. 3/8 visit the house only. The rest visit the museum only. In total, how much do the 480 people pay to visit the park? You may use the Venn diagram to help you. Okay, so we've got a little Venn diagram over here. Let's go through this line by line and see what we can do. One day, 480 people visit the park. We'll come back to that. We can't use it just yet. 67 people visit the garden only. That we can use. So if we've got house, museum, oh, that's actually already on there. Look, it's there, 67. Okay. Right, so 40% visit the house and the museum. What's 40% of 480? Final, original, multiplier. Final is what we want. Original is what we started with. 480 multiplier is 40%, which as a decimal is 0.4. Okay, so the final is what we want. So cover that up. So final equals original times multiplier. Okay, so then that is equal to 480 multiplied by 0.4. What's 480 times 0.4? My 8 looks weird. Let me just write that again. 480 times 0.4. 480 times 0.4. That comes out to be 192. Okay, so remember that was the people that were house and museum. And on the Venn diagram then, they're the people who belong in the middle then, aren't they? So that's 192 in there. Okay? And then we've got 3/8 visit the house only. What's 3/8 of the total then? So house only, that's going to be 3/8 of 480 then, isn't it? What's that? 3/8 of 480, that's 180, so that's house only, 180. Okay, so we dealt with that one. And finally we've got the rest of the visit the museum only, and we can work that out from the first fact that we had there. Forgot to write down 180 there. Yeah, we had 480 people to start with, and we know what all the other areas of my Venn diagram are. So museum only be the rest of the 480 then, isn't it? So what we're going to do is going to take those three numbers away from 480. It's going to be 480, which is everyone, minus the other three areas. So 67, 180, and 192. What's that come to? So 480 minus 67 plus 180 plus 192. Doesn't leave that many, does it? It means it leaves 41. 41 are museum only. So that goes in there. Okay. So then what is the total that they pay then to visit the park? So garden only is free. House only is £8, so we're going to be multiplying that amount by 8. House and museum is £12.50, and museum only is £7. Okay, so we're going to do those and add them up, aren't we? So then the total cost, let's get a bit more space. So then the total payments, that's going to be 180 times 8 plus 192 times £12.50 plus 41 lots of £7. What's that equal to then? Okay, job for the calculator. 180 times 8 plus 192 times £12.50 plus 41 times 7. I make that £4,127. Okay, not bad for a day's work. Question 7. Jeff and Kaz shared £270 in the ratio Jeff to Kaz of 2.6 to 1. How much more does Jeff get? Okay. So when we're dividing by a ratio, the first thing we need to know is the total number of shares, which we can get by taking the ratio and adding the two bits together. So 2.6 plus 1 means that if Jeff gets 2.6 shares for every Kaz is 1, then altogether there are 3.6 shares. Okay, so then we need to work out the number of shares there are in £270. So 270 divided by 3.6. What does that give me? So 270 divided by 3.6, that comes out to be 75 shares, or 75 rounds of dishing out money. So that means if we take the ratio of 2.6 to 1 and scale it up by a factor of 75, we should get the amount that the two receive. Okay, well, the one on the right, Kaz's one's pretty easy. 1 times 75 is 75. But what's 75 times 2.6? That's 195. Okay. So that means Jeff gets £195 and Kaz gets 75. Okay, so the difference then is going to be 195 minus 75. What's that? That's is that 120? It's 120 pounds. Question 8. The heel of a shoe exerts a pressure of 198 pounds per square inch. Convert this pressure into kilograms per square centimeter. Use 1 pound equals 0.45 kilograms and 1 square inch equals 6.25 square centimeters. Okay, now what's missing here is the formula for pressure. Do you know what it is? Pressure is equal to mass divided by area. Okay, so pressure is equal to mass divided by area. So the greater the mass, the smaller the area, the higher the pressure. Okay, so convert pressure in kilograms per square centimeter. So we know that it's 198 pounds per square inch, and we want to know what that is in kilograms first. So let's convert into kilograms first. We're going to use the 1 pound equals 0.45 kilograms first. So we're going to multiply then that 198 by 0.45. Okay, because mass is on the toplet. So we're going to multiply the top part here by 0.45 to convert pounds into kilograms. So 198 times 0.45 comes to 89.1. That's going to be kilograms per square inch. Okay, and then to go from inches into square centimeter, 1 square inch equals 6.25 square centimeters. Now, to convert then inches to square centimeters, we need to multiply the area by 6.25, but area is on the bottom, so actually another way of thinking about it is dividing by that then to convert it. So that's going to be equal to 89.1 divided by 6.25. Then what's that? Divide by 6.25. That comes out to be 14.256. And that's going to be kg per square centimeter. Okay, so that's the answer we're looking for, 14.256. Question 9. Rectangle ABCD is split into 4 smaller rectangles. 2 of the smaller rectangles are shaded. We're told that the ratio of 4 to x is 1 to 2. For rectangle ABCD, work out the ratio of shaded area to unshaded area. Give your answer in its simplest form. Okay, let's start with this bit down here. If the ratio of 4 to x is the same thing as 1 to 2, then that means x needs to be twice as big as 4. So that means x is equal to 8 then, doesn't it? So x is equal to 8. Okay, so that's going to be 8 centimeters. Okay, now if that's 8 centimeters, then we can see down here I've got 56 down here, and I know that 8 times 7 is 56. So I'm thinking that that distance from there to there must be 7, so that when I times it by 8, 7 times 8, I'm going to get 56 in there. Similarly, if I've got 4 here and that area there is 12, then this length here must be 3, so that I get 3 times 4, and that's equal to my 12 there. Okay, so that means then that this shaded area is going to be 3 times 8, which is 8, 16, 24, and this one is going to be 4 times 7, which is 28. Okay, so now I know all the areas of the various bits. The total shaded area then is going to be the 24 plus the 28, which is 4852 centimeters squared, and the unshaded area is going to be the 12 plus the 56, which is what, 68 centimeters squared. So then the ratio of shaded to unshaded is going to be 52 to 68. Now we need to give it in its simplest form. So do 52 and 68 have any common factors? Well, I think the easiest way to do it is, I kind of use the fraction key on my calculator to do it. So if I put in that as a fraction, 52 over 68, that's going to cancel down to 13 over 17, and basically I can just use the same numbers here on the ratio, so that's a ratio of 13 to 17. So that's just a little cheeky trick for you there. So the ratio is 13 to 17, and I think that's my final answer, 13 to 17. Question 10. A solid shape is drawn on isometric paper. There it is. And part A says, on the centimeter grid, draw the elevation of the shape from A. Okay, well, if you're standing at the point A, what are you going to see? If I'm standing over here, right, I'm going to see this face, aren't I? Right in front of me. And that face is a 2 by 2 rectangle. Okay, so I'm going to see that on my grid. So I'm going to draw a 2 by 2 rectangle to start with. So then that's the yellow bit, isn't it? Let me just shade that in as well so you can see it. Okay, but that's not all I can see. I can also see this from my vantage point. Okay, it's going to be a little bit further off, but I should still be able to see it. I'm not going to be able to see this side. That one I won't be able to see, or the top, or that side, but I'll be able to see that green bit. Okay, so I'm going to add that on as well. Now that is a rectangle which is a width 1 and a height of 2, isn't it? Okay, so I'm going to see a little bit extra on the side of this shape. Okay, it's not necessarily for you to shade it. I'm just shading it so you can see what I'm talking about really a little bit more clearly. Okay, you just need to draw the lines. But I've shaded in so I can refer to the various faces that you can see, that I can see, and so you get that idea from me. Okay, so that's the front elevation. Okay, now part B says draw a plan of the shape. Now you can think about the plan in two ways. You can either think of it as a bird's eye view looking down from the top. Okay, so that's the plan view from here. Or the other way of thinking about it is it's the footprint of the shape. So if you imagine that was like a cookie cutter, what shape would it cut out if you kind of punched it into the ground? Okay, that's what we need to draw. So I'm going to do that. I'm going to do it from the same perspective, so that A being at the bottom, and then I'm going to draw like the plan from what I can see. Now, if you look at the distance from there to there, how far is that? That's 1, 2, 3, 4, 5 squares. That's 2. That's 2. That's 1. That's 3, and that's 3. So that's what I need to draw. So I'm going to draw the 5 first. So I'm just going to shade that one as well so it's clear what I'm talking about. So that is the face that I'm seeing from above. But again, you don't need to shade it. I'm just really giving you an idea of what I can see a little bit more clearly. Question 11. Eric thinks of a prime number between 20 and 30. His number is x% of 125. Work out one possible value of x. Okay. So, right, what could the number be first? Prime numbers between 20 and 30. What are the choices here? Primes between 20 and 30. What are they then? 21, no, because that's 3 times 7. 23. 25, no. 27, no. 29. So there's only two, 23 and 29, aren't they? They're the two possibilities. Okay, his number is x% of 125. Okay, so x% of 125. Well, when you're finding x%, you are finding x 100ths of your amount, aren't you? So if x% of 125 is his number, then x over 100 times 125 is either 23 or it's 29. I'm going to go for 23 for now because I don't know. It's just the first one in the list. And I just need to pick one possible one. So I don't need to do both, just need to pick one and use it. Okay, so let's try and isolate x. Let's multiply both sides by 100 to start with. That leaves me with x times 125, or 125x, is equal to 2300 then. Okay, then so x is going to be 2300 divided by 125 then, isn't it? If I divide both sides by 125, that's going to cancel. And what is 2300 divided by 125? 2300 divided by 125. That's 18.4. So x is 18.4. It's not 18.4%, it's just 18.4 because x% is what we're using. So we're using x must be 18.4 by itself. Okay, good. Now I could work out for 29 as well, but it only wants one. I found one. I'm done. No point in wasting time. Let's move on. Question 12. Part of a regular polygon with 15 sides is shown. Work out the size of an interior angle. Okay. Now this is a regular polygon, so each interior angle, there's a formula for it, isn't it? It's you take the number of sides, n, you subtract 2, and so that tells you the number of triangles inside your shape, times it by 180 will give you the total of all of the interior angles, and then divide it by n will tell you what one regular interior angle would be. Okay, so that's a formula for interior angles of a regular polygon. So for a 15-sided, so for a 15-sided polygon, n is 15, so we're going to get 15 minus 2 times 180 over 15, or in other words, 13 times 180 over 15. What's that then? 13 times 180 divided by 15. That comes out to be 156 degrees. Doesn't it look about right? Well, it's almost a straight line, this one, isn't it? So it should be getting that way. Yeah, 156 degrees. Now, if you find that rule hard to remember, you can also just use the fact that interior and exterior angles sum to 180 degrees, because exterior angles are a lot easier to find. So if I extend that line outlet, then the exterior angle is this one here, and this one is just 360 degrees divided by n. So what you can do is do that first and then use that one, and the fact that angles on a straight line add up to 180 to give you your interior angle. Okay, so that also works. Question 13. A box is the shape of half a cylinder on top of a cuboid. Work out the volume of the box. Okay, so if that is half a cylinder, then on top there, that is a semicircle, and so the center of the circle is there, isn't it? Okay, what's its radius? Well, we know that this from here to here is 26 centimeters. So the radius then is going to be half that. It's going to be 13. So this circle is going to have a radius of 13. We need that one to work out the rest, don't we? So then the volume of the semicircle, a circular prism, I suppose you could call it, what's that going to be then? That's going to be a half of the volume of the cylinder, which is pi r squared h, which in this case is a half times pi times 13 squared, and then the height was actually the length. It's this one here, isn't it, which is it's the same as this, 15. Okay, times 15. Okay, I'm going to leave the answer in terms of pi because I'm not quite done yet. So I'm going to get 13 squared times 15 divided by 2. That comes out to be 2535 pi over 2. I'm just going to leave it like that because I need to work out the whole volume. So I need to add on the cuboid, which I'll do in a minute. So the volume of the cuboid, what's that then? That's going to just be length times width times height, isn't it? Okay, so the length is 26, width is 15, height is 4. So what's that? So that is 26 times 15 times 4. That comes out to be 1560. Okay, so then the total volume is going to be those two things added together then, isn't it? It's going to be the 2535 pi over 2 plus 1560. What's that then? So add on 2535 pi over 2. That comes out to be 5,541.9. I think I'm going to round that up to the nearest whole number. So that is 5542 what? Centimeters squared. Nope, cubed, because it's volume. 5542. Question 14. Phil sells ties. He increases the original price of each tie by 10% to £13.20. A month later, he announces a sale. Sale, 10% off all ties. Phil says the ties will be back to their original price because each change was by 10%. Is he correct? Tick a box, yes or no. Show working to support your answer. Okay, I think he's wrong because adding 10% is not the same thing as taking 10% away again. I'll show you why. Let's do the original price first. So let's do final original multiply. I want to know what the original price was before he added the 10%. So final we know is £13.20. Original is what we want to find, and multiplier is, well, he's increased the price by 10%. So if I've got 100% and I add on 10%, then that is 110%. Okay, which as a multiplier is 1.1. Okay, so then original is equal to, well, cover up the thing I want to find. Original, it tells me what to do with the other two. It's final over multiplier. Final divided by multiplier, which is equal to £13.20 divided by 1.1. So what's that then? £13.20 divided by 1.1. That means that the ties were originally £12. Okay, so when he bought them, they were £12. Okay, right, now what we're going to do is we are going to apply the 10% decrease to the normal price of the ties. Okay, so this time if I've got final original multiplier, then we want the final. That's what we're looking for. The original is the normal price of the tie that he sells, £13.20. This time I'm going to be taking 10% off. Okay, so if I've got 100% and I subtract 10%, I've now got 90%, which as a multiplier is 0.9, isn't it? Okay, so this time I want the final, so let's stick our form on that. It tells me what to do with the other two. Final equals original times by multiplier. Final equals original times multiplier. Okay, and that is equal to 13.2 times by 0.9. Okay, so this is going to be his sale price. 13.2 times 0.9. That comes to £11.88. So that's why it's wrong, because the original purchase price is £12. That's what he paid for them. Okay, he then put them on sale for £13.20, and then in the sale he reduced the sale price to £11.88. So he's actually selling them there at a loss. So for every tie he sells, he's losing 12p, isn't he, actually? Because he's selling for 12p less than what he bought them for. Okay, so that's why it's not the same. Question 15. A bias spinner can land on A, B, or C. The table shows the probabilities in terms of K of A, B, and C. Okay, and they're given algebraically in terms of K. And we need to work out the probability of B. Okay. Now, I'm going to be using the rule of completeness here, which means that if A, B, and C are all the possible outcomes, and it does say that up here that it can only really land on A, B, and C, then these three things need to add up to 1. 1 in probability is certainty, and you're certain to land on either A, B, or C because they are the only outcomes. Okay, so in other words, 0.5k plus 7k minus 0.15 plus 2.5k should sum to 1. Okay, all I've done is I've taken the three values in the table and I'm adding them together. Okay, so what have I got here? I have got some terms in k. There's one, there's another one, and there's another one, and I've got a number. So collecting like terms, 0.5k plus 2.5 is 3k, plus 7k, that's 10k altogether, isn't it? So I've got 10k minus 0.15, that's equal to 1. So adding 0.15 to both sides, I'm going to get 10k is equal to 1.15, and so then k is 0.115. Okay, so what is the probability of B then? So if k is 0.115, then B is going to be 7 lots of 0.115 minus 0.15. What's that then? 7 times 0.115 minus 0.15. I make that 0.655. 0.655. So the probability of B then is 0.655. Question 16. P is the point 214, Q is the point 6a, and R is the point 25. Use gradients to show that the angle PQR is not a right angle. Okay, I think what I'm going to do here is do a little sketch-a-rooney here so I can get kind of an overview of what's going on. Okay, it doesn't have to be to scale, it doesn't have to be super accurate, but I just want to get an idea of what's going on. So I've got the point 25, so that's going to be R, which is at 2, 5. Okay, and then I've got Q, which is 6, 8, so 3 times further along and kind of a little bit higher up. So that is Q at 6, 8. I've got P at 2, 14, so that's above R quite a lot higher up, so like up there. Okay, so that's my point P, and it's at 2, 14. Okay, I'm just going to join those up. I think it helps to have a little sketch, otherwise you're kind of holding too much in your brain, and you know, I think a nice little sketch kind of helps. Okay, so what do we want to do? We want to use gradients to show that PQR is not a right angle. Where's PQR? PQR, PQR. So we're talking about that angle in the corner then, aren't we? Okay, so this angle. Okay, so we need to find the gradient of PQ, which is this line. And we need to find the gradient of QR, which is this line, and we need to show that they are not perpendicular to each other, not at right angles. Okay, so that's what we're going to do. How do you find the gradient of a line? You can use the gradient of a line, m is equal to y2 minus y1 over x2 minus x1. That's the formula, isn't it, for two coordinates x1, y1 and x2, y2. Okay, so, and we're going to use that formula for finding the gradient of PQ and for QR or RQ. I'm not quite sure which way we're going to do it, but anyway, let's go and do that then. So for line PQ first, let's start with PQ. Then we're going to use gradient. I'm going to make it M1 so I can have a different gradient for the other line. So M1 is equal to, so let's make this one x1 y1, and we'll make this one x2 y2. Okay, so then I've got y2, which is 14, minus y1, which is 8, divided by x2, which is 2, minus x1, which is 6. So what's that? 14 minus 8, that's 6. 2 minus 6, that's negative 4. So that comes out to be, let's just cancel it down, that's negative 3 over 2 then, isn't it? Okay, so that's my gradient for M1. Right, now we're going to do the other line. So for line RQ, okay, now again, I'm gonna change. So this is no longer my point x2. Let's make this one. I'll keep that one the same. x2 y2 is here. Look. Okay, so then using the same formula, M2, my second gradient, is going to be y2, which is 5, minus y1, which is 8, divided by x2, which is 2, minus x1, which is 6. So what's that one then? 5 minus 8 is minus 3. 2 minus 6 is minus 4. Negative divided by a negative is positive, isn't it? It's just 3/4. Okay, so are they perpendicular? So let's take the gradients M1 and M2 and multiply them together. Now, if they are perpendicular, we should get a value of negative 1. Okay, so let's multiply them. Okay, that does not equal negative 1, does it? And that gives me minus 9 over 8, which is not equal to negative 1. Okay, 9/8 is not equal to negative 1. Therefore, PQ is not perpendicular to RQ, and so PQR cannot be 90 degrees. Okay, Question 17, m squared is greater than 9. Circle the possible values of m. Well, I already know what it is, but assuming you doesn't leap out at you, then the easiest thing to do is just to square all those numbers to see if it's bigger than 9. Okay, so which ones give you a number bigger than 9? So if I've got 2 and 7/8, and I square that, just tap it into the calculator and using the square button, that comes out to be 8.265 and change. So it's roughly 8.26. It's 8.27. It's just too small, isn't it? That's not bigger than 9. 2.8, I already know is not bigger than 9. 7.84. Similarly, 3 squared is 9. 9 is not bigger than 9. The only one that can be bigger than 9 is that one at the end. I'm just going to show you. If you've got negative 7/2 and you square it, that gives me 12.25. Okay, now I spotted that one straight away because 7/2 is 3.5, and if it's negative 3.5, it's just going to give, when you square a negative number, it's still going to give you a positive one. So I could spot that that one was going to be the right answer. But anyway, if you don't know, just square them, it will tell you. Question 18, simplify w to the power 1 times w to the power 0. So we've got two numbers with the same base, and we're multiplying them together, so we should add the indices together. So that is going to be w to the power of 1 plus 0, which is still w to the power 1, which is just w, so it's that one there. Another way of thinking about it is w to the 0, anything to the power 0 is 1. And w to the 1 times 1 is w to the 1, it's still w. Okay? Question 19, the equation of a circle is x squared plus y squared equals 11. Work out the length of the diameter. Right, well, the equation of a circle is always of the form x squared plus y squared equals r squared. Okay, so comparing this, x, y, 11 r squared, we can see that r squared is equal to 11, and isn't it? So then r is going to be the root of 11. I don't see the root of, oh yeah, I do see the root of 11 there. There it is. Okay, but that's the radius. I do see root 11 there. I was quite tempted to do that, but I would be wrong, wouldn't I? Because it actually asks for the diameter. Okay, it's in bold. Usually things in bold are things that students and teachers sometimes miss. So a diameter then is going to be twice the radius. So the diameter is going to be 2 lots of root 11. It's going to be that one there. Question 20. A over b is 3c and b over c is equal to 2. Work out the value of a when c is equal to 8. Okay. So we've got simultaneous equations here, haven't we, in a, b and c. What we're going to have to do, if you notice, I want to find the value of a when c is equal to 8. So really what I want to try and do is combine these two equations together, and so by eliminate b. Okay? So what we're going to do is take, let's call them equation 1 and equation 2. I'm going to rearrange equation 2 first. Rearrange 2. And so I'm going to get b is equal to 2c, just cross multiplying that c, or multiplying both sides by c, and then I'm going to substitute into equation 1. What's that going to give me then? So a over b, well, b is now 2c, so a over 2c is equal to 3c. Okay, so then cross multiplying the 2c, or multiplying both sides by 2c, times 2c times 2c, they're going to cancel, leaving you with a on the left, and then 3c times 2c, that'd be 6c squared then, isn't it? Okay, so when c is equal to 8, what's a? A is going to be 6 lots of 8 squared then, isn't it? 8 squares is 64, and 6 times 64, that comes out to be 384. 384. A is 384. Question 21. Here is some information about the ages of babies at a clinic. And we've got ages from 0 to 5, 5 to 10, 10 to 20, and 20 to 50 weeks, and their frequencies. We're asked to draw a histogram to represent the information. Now, to draw a histogram, we need frequency density, and to find frequency density, we need class width. So that's what the two extra columns on the table are. So we're going to make class width 1, and frequency density is the other one. Okay, and now frequency density is equal to frequency divided by class width, which is why we need to know the class width. Okay, we know the frequency, we don't know the class width yet, but we can find it, and then we can find frequency density, can't we? So the class width from 0 to 5, 5 take away 0 is 5. The class width of 5 to 10, 10 take away 5 is 5. The class width of 10 to 20, 20 take away 10 is 10. And from 20 to 50, 50 take away 20 is 30. So they're my class widths. Then to find frequency density, what we're going to have to do is divide frequency by class width. So 18 divided by 5, that is 3.6. 3.6. 23 divided by 5, that is 4.6. 17 divided by 10, I know, that's 1.7. And 21 divided by 30, I know, that's 0.7. Okay? Right, so now I know the heights of all my bars because it's frequency density that needs to go on the scale, this one. And we draw the bars using our class widths. Okay, this is where they start and end. So we're going to be plotting those start and end points against these frequency density. That's what we're going to use. Okay, so the first bar runs from 0 to 5 and it has a frequency density of 3.6. So let's rule 3.6 first. Now each one of these, I've got between 2 and 3, I've got 10 divisions. So each one of these is just 0.1, isn't it? It's a nice easy scale to use. Okay, so I'm going to draw a bar from 0 up to 5. Okay, like that. Let's just turn the rule around and close off the first bar. Okay, the next one is from 5 to 10 with a height of 4.6. Next bar goes from 10 to 20 and it's at height 1.7. And the last one goes from 20 to 50 at a height of 0.7. Okay, all done. A sequence of patterns is made using horizontal sticks and vertical sticks. So I've got pattern 1, pattern 2, pattern 3 shown. The table shows the number of horizontal sticks and vertical sticks in each pattern. Okay, so the number of horizontal sticks is going up in 2 each time, 2, 4, 6, and the vertical is going up by 1, 2, 3, 4. What fraction of the total number of sticks in the pattern n are horizontal? Give your answer in terms of n. Okay. Right, so this first sequence, number of horizontal sticks, that is a linear sequence. It's going up in 2s, isn't it? So this would be 2n. Okay, so the first pattern is 1. 1 times 2 is 2, so that actually fits. And this second one is going up in 1, so it has something to do with n, but it's actually 1 more than n. It's n plus 1, isn't it? So the nth term is going to be 2n and n plus 1 for their nth terms. So what fraction of the total number of sticks in pattern n are horizontal? Well, what fraction? A fraction is compare what you've got with everything. So fraction that is horizontal, that is going to be the number that is horizontal, which is 2n, divided by everything, which is those together, isn't it? 2n plus n plus 1. 2n plus n plus 1, which if I tidy that up, that's 2n over 3n plus 1. Okay, that's it. That's all I need to do. 2n over 3n plus 1. Question 23. The equation of a curve is y equals 16 to the power of x. Circle the point that lies on the curve. Okay, now y equals 16 to the power of x. Can you see that my x value is the exponent or power? So this is what we call an exponential function, which increases very quickly. If you were to graph it, it would shoot up like that. Okay. Now, which of those points lie on the line? It's just about a matter of putting the values in to see if they hold, isn't it? So for this first one, 2 and 32, the first one is our x value, isn't it? And the second one is our y value. So if y equals 16 to the power of x, if this point is on the line, then those values should work in the equation. So y, 32, should be equal to 16 to the power of 2. Is 16 squared equal to 32? I don't think so. That's wrong, isn't it? So I don't think 32 lies on the line. Let's try the next one. If x is 32 and y is 2, is 2 equal to 16 to the power of 32? I don't think so. That one's definitely not right either. What about the next one? X is 2 when y is 256. Is 256 equal to 16 to the power of 2? I don't know. What is 16 squared? 16 squared, it looks possible though. Yeah, that's 256. That one lies on the line. So I'm going to circle that one. I'm just going to double check the last one. Well, I can just see straight away it isn't going to work. 2, it cannot be 16 to the power of 256. That is never happening. Okay, so no. Okay, so it's 256 that lies on the line. Part B says a different point on the curve has a y coordinate of 1 over 16. Work out the x coordinate. So if y equals 16 to the power of x and y is equal to 1 over 16, then 1 over 16 has got to be equal to 16 to the power of x. Okay, so what power turns a number into its reciprocal? 16 and 1/16 are reciprocals of each other. So I know straight away what that is. That has to be that x is equal to -1, isn't it? Because anything to the power of -1 kind of flips the fraction upside down. So 16 to the -1 is going to be 1 over 16. Question 24. A to the power of b is equal to 3, where a is an integer and b is a proper fraction. Work out one possible pair of values of a and b. So a is an integer and b is a proper fraction. A proper fraction is something that looks like this, one number above the other, where d is bigger than c. Or I suppose, yeah, is it bigger than or equal to? I suppose it could be the same number, I suppose, and still be a proper fraction. Yeah, so that's the rule. Okay, so it needs to be a fraction where the number on the top is smaller or the same size as the number on the bottom. Otherwise, it's an improper or top-heavy fraction. And we know that a is an integer. Integer is a positive or negative whole number. Okay, so now we know what that word means and that word means. Then we know we can maybe proceed. Okay, so a is going to have to be an integer, a whole number. And if I then raise it to a fraction and I get 3, what could it be? Okay, well I could let b equal a half. B is a half is a proper fraction, isn't it? And I know what a fraction of a half does. It's the square root. So if I take a number and I raise it to the power of a half, that would be square rooting it, and I get 3. Then a is going to be 9, isn't it? So 9 to the power of a half equals 3. Does that work? Yes. 9 is an integer. So a is 9. B is a proper fraction. It's a half. and then a to the power of b then is 9 to the power of a half, which is 3. I think we are winning 9.5. Now I'm pretty sure there are going to be other values that work in this. It's quite a loose relationship. So, but it does say that we only need to find one possible pair. I'm not having to find all of them. I found one, so that's it. We can move on. Question 25, expand and simplify fully x minus 3, x plus 2, x plus 5. What fun, we got a triple bracket. Nice. So let's start x minus 3, x plus 2, x plus 5. Okay, what I do with these is I just start with one pair and multiply those out first, and I leave the one on the front untouched for now. We'll come back to that one later. So that's going to be equal to x minus 3, which we're going to leave untouched, and then we're going to multiply out the other bracket, so whatever method you like to use. First outside, inside, last, or 2 eyebrows, a nose and a mouth, or grid method, whatever you want to do. I'm going to multiply that out. So I'm going to get x times x, which is x squared, and I'm going to get 2 times x, which is 2x, x times 5, which is 5x, and 5 times 2, which is 10. Okay. Now note I've just got a couple of terms in x in the middle, so before we go do anything else, I'm just going to tidy those up and make that x squared plus 7x plus 10. Okay, now we're ready to go again. So what we're going to do now is we're going to multiply everything in the second bracket by x, and then we're going to multiply everything in the second bracket by negative 3. Okay, so what's that going to give us? Let's do the x first. X times x squared is x cubed. X times 7x is 7x squared. X times 10 is 10x. Okay, now we're done with the x's. Time to switch to the minus 3. I'm going to drop down a line, and I'm going to come across a little bit. I'm going to show you why in a minute. Negative 3 times x squared, rather than writing it here, negative 3x squared, I'm not going to do that. I'm going to drop down, and I'm going to write it under my existing x squared term. Okay, this will become apparent why in a minute. And then negative 3 times 7x, that's minus 21x. Again, I'm going to write it under the existing x term. And then negative 3 times 10, that's minus 30. I'm going to write it under the non-existent constant. Okay. Now the reason I did that is because then I could kind of add up along here. I can add this. Well, there isn't anything to add. I can add those. I can add those. And I can add those. Okay, so just by arranging it like that, it just makes the collecting like terms a little bit easier. It's just a bit of a pro tip. So just got an x cubed in this column. I got 7x squared minus 3x squared. That is 4x squared. I've got 10x minus 21x. That is minus 11x. And I've got minus 30 on the end there. Okay, so that's my expression. X cubed plus 4x squared minus 11x minus 30. Question 26. Here are two similar cones. We've got cone A, which is equal, and cone B, which is big. The surface area of cone A is 2 square meters, and the surface area of cone B is 4.5 square meters. Work out the ratio of the radius of cone A to the radius of cone B. Give your answer in the form 1 to n. Okay. Now, the key word here is that these are similar. And when you've got similar shapes, then the ratio of their lengths, areas, and volumes are in a pattern. So let's say the ratio of their lengths is in the pattern A to B, then their areas are going to be in the relationship of A squared to B squared, and their volumes are going to be in the relationship of A cubed to B cubed. Okay, so that is good and handy to know about. Okay, so that's what we're going to be using to answer this problem. So the surface area of a cone A is 2, and the surface area of the cone B is 4.5. Now, surface area is a type of area. Okay, and area, so the area ratio of A to B is in the ratio of 2 to 4.5. Okay, now we want to work out the ratio of their lengths. So if we want to go from area to length, so what we're going to have to do is going to have to square root our two ratios. Okay, I think what I'm going to do first, I'm going to get into the form 1 to n, because then when I square root, it's going to stay in the form 1 to something. So it should make it a little bit neater. Okay, so what I'm going to do first is I'm going to rewrite that as 1 to half of 4.5. That's 2.25. Okay, and then if I want to then work out, if I want to go from there to the ratio of their lengths, I'm going to have to square root then, aren't I? So the square root of 1 is just 1, and the square root of 2.25 is root 2.25. What is root 2.25? I think that's 1.5. Let's just double check. Root of 2.25, yes, 3 over 2 or 1.5. So that is the ratio of 1 to 1.5. Now this ratio applies to all lengths that you can measure on this diagram. Okay, so radius is a type of length, so the radius is going to be in the form 1 to 1.5. Okay, so the radius of cone A to the radius of cone B is just going to be 1 to 1.5, because it's a length like any other length on the shapes. So let's just say ratio of radius A to radius B, just so it's nice and clear, 1 to 1.5. Question 27. In the diagram, the vector from D to E is A, D to H is B, and H to G is 8B. The ratio of EX to XH is 3 to 1, and the ratio of EF to FG is 1 to 3. Show that the vector D to X is a quarter of A plus 3/4 of B. Okay, what have we got here then? So D to E, is that marked already? Yes, it is. D to E is here, look. Is D to H already marked? Yes, it is. D to H is here. Is H to G already marked? Yes, it is. It's down here, look. EX to XH equals 3 to 1. Is that already marked? EX to XH, that's that one there, look. So that is in the ratio of 3 to 1. So that means 3 parts up here for every 1 part we've got down here. And then finally we've got EF to FG, and that is in the ratio of 1 to 3. So that is 1 part to 3 parts along there. Okay, right, I'm just going to get rid of that color because too much. Okay, and then let's have a look at what we can do here. So I want to find the D to X. Where's D? D is here, look. Where's X? X is up here. Okay, now I want to go from D to X. Now I have to go along routes that I know. Okay, so to get from D to X, I would need to go, well, I can go along this one. I know that one, don't I? That's just B. But then I'd have to go up this line here. Okay, but I don't know that one. But I do know it's part of this line. It's like a quarter of it. And I can get from H to E via a different route. So I think what I'm going to do first is I'm going to find H to E. Okay, as a vector. What is the vector H to E? Okay, once I know H to E, then I can find H to X. And once I know H to X, I can find D to X. That's my plan. Okay, so I've got my plan. Let's execute plan. Right, H to E. If I want to go from H to E along vectors that I know about, I can go from H to D along that green line, and then I can go from D to E along that yellow line. Okay, so vector H to E, that is the same thing as H to D plus D to E. And that is equal to, well, it's minus B plus A. Okay, which you could write as A minus B, probably a little bit neater. I'm going to just spin that around and write that as A minus B. Actually, because it's minus B that is the H to D part, and then A is the D to E part. Okay, but it's A minus D. Okay, now I can't draw bold, so I'm going to draw those with little kind of hats on like that. Right, so I've done that one. Let's do h to x next. H to x is a fraction of h to e, isn't it? Okay. Now, if h to x is one part to every 3 parts we've got on the other side, then h to x is a quarter of h to e, isn't it? Because 1 plus 3 is 4. Okay, so it's 1 part out of 4 parts of the distance from h to e. Okay, so hx, I'm going to say, is 1/4 of h to e. Okay, now I just found h to e. It was a minus b. So h to x is 1/4 of a minus b. Okay, doing good, doing good. Right, and then finally, d to x. D to x then is d to h, which we know, plus h to x, which we know. So d to h is b, and then h to x is 1/4 of a minus b. What's that then? So just removing the brackets, I'm going to get b plus 1/4 of a minus 1/4 of b, which is equal to 1/4 of a. B, take away 1/4 of b, that leaves me with 3/4 of b, which spookily is what I was looking for. There it is down there. So 1/4 of a plus 3/4 of b. Good, we're done. Okay, so that was my workings for part A. Part B says, is dxf a straight line? Show working to support your answer. dxf. Okay, so d to x and x to f. It could be. Okay, now this diagram is not to scale. Now, if dxf is a straight line, then dx and f are what we call collinear points, which means that the vector d to x must be some multiple of the vector x to f, or the other way around. Okay, so if dxf is a straight line, now I could show that d to x is a multiple of x to f, or I can go d to x and d to f. I think that might be the easier route. If I can show that vector d to f is a multiple of the vector d to x, then that would imply that all those 3 points lie in a straight line, because they're sharing a starting point, d. Okay, and then if they have the same, if one is a multiple of the other, then they're going in the same direction, and therefore they should skew all the same points. Okay, so that should be sufficient proof if I can show that d to f is a multiple of d to x. Okay, I did think about doing d to x and x to f first, but like that would be too much work, whereas d to f looks a little bit easier to find. Okay, what is the vector d to f then? Now, to find d to f, presumably we are going to go from d to e along the yellow route, and then from e to f down here. I don't know that yet, but I can probably find e to g using e to d, and then d to h, and then h to g. Okay, so I need to find e to g, so then I can find e to f, and therefore I can find d to f. That's the plan. Okay, sounds like a great plan to me. So we need to find e to g first. So vector e to g, that is going to be e to d plus d to h plus h to g, isn't it? Okay, which is going to be e to d is minus a, d to h is b, and h to g is 8b. Okay, so what's that all together? That is 9b minus a. Just going to spin it around just to use one less sign. Okay, so now I know e to g, I can find e to f. So e to f then is going to be a fraction of e to g. What fraction is it? Again, I've got these in the parts 1 to 3. So e to f is 1 part out of 4 parts. So it's going to be a quarter of e to g then, isn't it? Okay, which is going to be a quarter of 9b minus a then. Okay, and then now I know e to f, I should be able to find d to f. So then d to f, that is going to be d to e plus e to f. Have I got space to do this? I think so. D to e is a, and e to f is a quarter of 9b minus a. So then what's that equal to? That is equal to, I've got a whole a minus a quarter of a, so that is 3/4 of a. And I've got 9b divided by 4, so that's 9b over 4. And they're both going to be positive. So 3/4 of a plus 9/4 of b. Okay? Well, I can see already, if I factorize out 3 out of that, then I should be onto a winner. Okay, so if I then factorize 3 out, I'm going to get, I'm just going to move that up a little bit because otherwise I'm going to run out of space. So if I factorize a 3 out of those two terms, I'm going to get 3 lots of a quarter of a plus 3/4 of b. Now you might wonder why I just factored 3 out and not 3/4, because a 4 could come out as well. But I'm using the fact that a quarter a plus 3/4 of b, if you remember, is my vector dx, isn't it? Okay, so I can then say then that d to f is 3 lots of the vector d to x, which is what I wanted to show then, wasn't it? If you remember right back at the beginning, I said that I wanted to show that df was equal to some multiple of d to x, which is what I've done. Okay, so therefore dxf is a straight line. Awesome job. Question 28. A equals 4.72 to 3 significant figures. B equals 1.58 to 3 significant figures. Work out the upper bound of A over B. You must show your working. Okay. Now when I'm doing these limits of accuracy questions, I like to draw a number line and mark on the number they give me. So that is 4.72. Now, that's been rounded to 3 significant figures. Now the third significant figure is that 2 there, which is in the hundredths column. So 1/100th more than 4.72 would be 4.73. So one number up on my number line is going to be 4.73. 1/100th down would be 4.71. So then the numbers that are going to round to 4.72 are going to be like halfway between those or closer, aren't they then? So this range of numbers here. Okay. So the lower bound for A is going to be 4.715 because that's halfway between 4.71 and 4.72. And the upper bound is going to be 4.725 because that's halfway between 4.72 and 4.73. Okay, now that's A. I'm going to do the same thing for B. B is 158 to 3 significant figures. So I'm going to draw another number line. I'm going to mark on the number they gave us, which is 158. Now this time the third significant figure is that 8 there, isn't it? 1, 2, 3, it's the 8. So that means this number's been rounded to the nearest unit or whole number. So one whole number up from 158 is going to be 159. One whole number down from 158 is going to be 157. So that means that the numbers that round to 158 are going to be halfway between those or closer. So this range, all these are going to round to 158. That lower bound there is halfway between 157 and 158. That's going to be 157.5. And the upper bound is going to be halfway between 158 and 159. That's going to be 158.5. Okay? Right. Now we need to work out the upper bound of A over B. Okay? So we've got two possible values of A that we're going to use. So we're going to use the upper bound and the lower bound. And then we've got two possible values of B. And we want to pick the values of A and B that are going to deliver us the largest value of A divided by A divided by B. So A divided by B, what's that then? Now to get that as big as possible, I'm going to pick the biggest value of A that I can, which is that one, isn't it? Okay, I'm going to pick my biggest A, which is 4.725. And I'm going to divide it by, now, do I want the biggest or the smallest value of B? If I pick the biggest one, I'm going to divide A by a bigger number and I'm going to get a smaller result than if I divide it by the smaller one. I'm going to get the bigger result, aren't I? So I'm actually going to use the lower bound of B, because that is going to deliver the largest value overall for A over B. Now if you can't figure these out, the alternative is just to try all the various combinations. There should be 4 combinations altogether. Try upper with upper, lower with lower, upper with lower, lower with upper. You just work all 4 of them out and then you see which one delivers you the bigger one. I'm pretty good at reasoning it out, so then I'd rather spend the time reasoning and do the calculation once. But if you're not able to reason it out that way, then like I say, the alternative is just to work out like a brute force attack. Just work all 4 out and then you see which one is going to give you the biggest number. Right, I'm pretty confident this will though. So 4.725 divided by 1.57.5, that comes out to be 0.03. Okay, so that is my upper bound. So that is my upper bound of A over B. It's 0.03. Okay. Question 29. A, B, and C are 3 points on the circumference of a circle centre O. BD and CD are tangents to the circle. ABDC is a kite. Angle BDC is equal to X. Prove that angle ABO is equal to 45 minus X over 4. Okay. Right, now there's a lot of blurb above the diagram. I'm quite particular. I like to go through all of this and just double check it's on the diagram, because not always so. So BD and CD are tangents to the circle. Okay, so what does that mean? Okay, so we've got BD, these are tangents here, look. Okay, that means that that angle there must be a right angle and that angle there must be a right angle, because of tangents are perpendicular to radiuses drawn at the point of contact. Okay, and then I've got ABDC is a kite. Now that means that that side and that side are equal in length, and that one are as well. Okay, so that also means that we can, well, I don't know what it means. Let's find out what it means in a bit. And finally, angle BDC is X. Now that has been marked on the diagram. Now we want to prove that angle ABO is something. Where is ABO? ABO is that angle there. Okay, so eventually we want to find that. Okay, now with most of these problems though, that is not your starting point. Okay, your starting point is going to be a long way away from that. Okay, all right, so what can we start with? I would start with the things that we know about. So I actually know about this angle here, X. Now I know that X, and I said earlier that I put 2 right angles on. I suppose we should, if we're going to prove it, we need to write that down. Okay, I'm going to say that OBD and OCD are right angles, and the reason I know that because I'm going to give reasons for everything, is tangents are perpendicular to radius drawn at point of contact. Okay, so it's good to write down the reasons. Okay, so I know that they're right angles, and I know that OBDC is a quadrilateral. So it's angles sum to 360 degrees. Okay, so I know X, I know 90, but I don't know BOC. So angle BOC, that's got to be equal to 360. Okay, so I know that 90 and 90 is 180. And I take that away from 360, that's going to leave me with 180. So angle BOC then is going to be 180 minus X, just simplifying that down a little bit. Okay, so I know that that angle there is 180 minus X. Now I also can see that that is the angle at the center, and this one here is the angle at the circumference, isn't it? Okay, so I know that these two are related. I'm going to use the fact then that CAB is going to be a half of angle BOC, which is a half of 180 minus X. Okay, which is, multiplying out the brackets, that's 90 minus X over 2. Okay, I've kind of got halfway then, isn't it? I've kind of got halfway to where I need to get to. So CAB is equal to 90 minus X over 2. And the reason for that is that angle at the center is twice the angle at circumference. Okay, so that's that. So now I know that that must be 90 minus X over 2. So then how can I find that one over there then? Well, I suppose it's got to do with the fact that ABDC is a kite, because that means that that angle and that angle are equal to each other, and we can use the angles inside the kite add up to 360 to take away the two ends and then divide it out between those two angles then, can't I? So I can say that in kite ABDC, okay, so I know the two ends, don't I? X and 90 minus X over 2. Then so I can say that ABD, angle ABD, is equal to angle ACD, because it's a kite, and angle ABD plus ACD plus CAB plus BDC must be 360, because it's a kite. It's a quadrilateral, isn't it? Okay, so what do we know there? ABD we said was 90 minus X over 2. That's ACD is equal to ABD, so I'm going to just replace that as two lots of ACD then, because they're both the same. And then BDC I know is X, and that's all equal to 360. Just going to scroll this up a little bit because I'm running out of space. Okay, so what now then? So I've got 90 minus X over 2 plus X, so that's going to be 2ACD plus 90. So minus x over 2 plus x is just going to be plus x over 2, and that's equal to 360. So taking 90 away from both sides, I'm going to, and the x over 2 away from both sides, I'm going to get 2ACD is equal to 360 minus 90 is 270 minus x over 2, and then dividing it by 2 then ACD, just one lot of ACD, is just going to be half of 270, which is 135, minus half of x over 2, which is x over 4. Okay? But if you remember, ACD is equal to OBD plus ABO. Okay, so our 135 minus x over 4 is going to be equal to OBD, which was a right angle, 90, plus ABO, which is the thing we're trying to find, isn't it? ABO. Okay, so then taking 90 away from both sides, that is going to give me 45 minus x over 4 is equal to ABO then. Okay? Okay, so that was quite a long proof, but prove it we did. Okay, so very good. So ABO is 45 minus x over 4. So just running through that again from the top, we used the fact that tangents and radius is at right angles to find those right angles. Then we used the quadrilateral OBDC to find the angle at the center, and then once we had the angle at the center, we found the angle at the circumference, that's at A, and then we used the kite to find ABD, and then we took away 90 and we found ABO. Awesome, good job. Let's move on. Question 30, a sphere has radius r centimeters. An approximate value of r can be found using the iterative formula Rn plus 1 equals the root of 239 divided by Rn. The starting value is R1 is equal to 7. Work out the values of R2 and R3. Okay, so what I like to do with these is I like to type in the first value into the calculator and then press equal, so it's the last stored value. Okay, and then I'm going to get the next value by taking the square root of 239 divided by Rn, which I'm going to use the answer key. So basically the last calculated value is going to come back and go into there. Okay, so R1 we know is 7, then R2 is going to be the root of 239 over 7, and I'm just going to press my answer key and find out what that is. That's equal to 5.843. I'm just going to write it down to 4 significant figures for now. 5.843, and then R3 we're going to get, all I need to do now is I'm going to write it out, so that's going to be 289 over 5.843, but because we get the way we set it up on the calculator, all I have to do is press the equal button again, and it's going to feed in R2 into the formula, and it's going to give me R3 straight away. So that's 6.395, and again we're just going to write down the first 4 significant figures for now, so that's 6395. Okay, so we're done with that. Part B says continue the iteration to work out the radius to 1 decimal place. So basically we're just going to have to keep on finding more and more values until it settles down on the first decimal place and we start getting the same answer over and over again. So we've already got R3, so let's go on to find R4. Now again, I'm just going to press the equal button. That's going to feed in my R3 value and give me the R4 value. And again, I'm just going to write down the first 4 significant figures, 6.113. And I'm going to keep going until it settles down. So then the next one, R5 is equal to 6.253, and then R6 is equals 6.183. Still jumping around a little bit, and wait until it settles down. R7 equals 6.218. Still bibbling between 1 and 2. Next one, R8 equals 6.200. R9 equals 6.209. And R10 is equal to 6.2. It seems to have settled now, doesn't it? 204. So the last digit is still kind of resolving itself. And then I've got R11 is 6.207. And then the next one. And if I keep pressing it now, I think I'm just going to keep pressing it now. Can you see it just kind of resolves to 6, goes down to 6.2058. Just going to round off to 6.206. That's where it kind of settles to. Okay, so then you can see that to one significant figure actually settled pretty quickly. It settled on the 6 from the first, well, from the second, from R3, didn't it? And then it started being 6. But it didn't really settle on the second decimal place until we got to R7, R8, and then it stayed being 2. Okay, and then you can see then we started getting the third decimal, the third significant figure there, and it took a little bit while longer for the fourth digit to settle down. But we just want to know what the radius is to one decimal place, so that is equal to, so the radius is equal to 6.2 to 1 dp. Okay. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.